A gardener plans to enclose part of their garden with rope. The total area being enclosed is 60 meters squared. This will be divided by rope to make 8 identical rectangular areas, x by y meters. Question A. Find an expression for y in terms of x. 8 identical small rectangles form also a rectangle, and the area of a rectangle is just width times length, and hence total area 60 is, you can see that it's 4x by 2y rectangle, hence it's 4x multiplied by 2y, and hence y is 60 divided by 4 times 2 times x, and we can divide numerator and denominator by 4 to get just 15 over 2x. The next question B shows that the total length t meters of rope required is given by. So the total length required, you can see that it's 4x times 3, which is 12x, plus 2y times 1, 2, 3, 4, 5, so plus 10y, and substituting this for y, we get that it becomes 12x plus 10 times 15 over 2x, and you can see that it becomes 12x plus 75 over x as required. Question C. Find an expression for dt over dx is derivative of t with respect to x, and you can see that t is the sum, and derivative of a sum it's the sum of derivatives, and just applying x to the power of n, derivative is n x to n minus 1, and it becomes derivative of 12x, it's constant multiplied by a function of x. Derivative is constant multiplied by derivative of a function, and x to the power 1 derivative, it's 1x to 1 minus 1, it's to the power 0, which is just 1. So x derivative is just 1, hence it's just 12 multiplied by 1, so just 12. And notice that you cannot take a derivative when x is in the denominator. You should rewrite it to be in the numerator firstly, so you should rewrite as 75 times x to negative 1 firstly, and again it's constant multiplied by a function, and derivative becomes constant multiplied by the derivative of a function, so 75 multiplied by the derivative of x to negative 1, which is what? Just negative 1 x to negative 2, and x to negative 2 it's x to the power of 2 in the denominator, so finally it's minus 75 over x squared. When x is k, derivative is 0, so just equating 12 minus 75 over x squared to 0, we need just solve for x, and you can move it to another side to get that 12 is 75 over x squared, and then multiplying both sides by x squared and dividing both sides by 12, you get that x squared is 75 over 12, or fraction is equal to fraction, it's called a proportion, and you can move factors along diagonals. X squared moves to the left up and 12 moves to the right down, and you get this. Or you can make a common denominator and get that it's 12x squared minus 75 over x squared, and fraction can be equal to 0 only when numerator is equal to 0. And then in general it's plus minus, x is plus minus square root of this, but since x is length, it cannot be negative, so it's positive. It's positive square root, it's just plus square root of this. But you can notice that we can divide numerator and denominator by 3 to get 25 over 4, and x is just positive only square root, which is what, 5 over 2, and it's the required value of k. It's where derivative is 0. Then calculate the value of t when x is k. So we need just find t of 5 over 2, substituting 5 over 2 for x into t. We get that it becomes 12 times 5 over 2 plus 75 divided by 5 over 2. To divide by a fraction, we need just multiply by reciprocal, and it becomes 30 plus 30, which is 60. Then next, find the value of y when x is k. Y is 15 over 2x. So it's 3. The next, find the second derivative of t, and it's what derivative of the first derivative of this, and again derivative of sum of difference, it's sum of difference of derivatives, and it's just a constant without something of x, and derivative of a constant, it's 0, so it disappears. And again, you should rewrite this x squared as x to negative 2, and derivative becomes what? Negative 2x to negative 3, and hence it becomes (150) divided by x cubed. And justify whether t has a local minimum or local maximum at x is k. And to be local minimum or local maximum, the necessary condition is that derivative must be equal to 0, and it's x over 2. It's also called the stationary point. It's where there is horizontal tangent, but it may be local minimum or local maximum, or neither. It's just point of inflection, something like this. And to state whether it's local minimum or maximum, one of two methods we use is to find the second derivative, and when the second derivative at this point where the first derivative is equal to 0, when the second derivative is greater than 0, hence it's local minimum, and when the second derivative is less than 0, it's local maximum. Why? Because second derivative is greater than 0, it means that curve is concave up at this point, at that point, and hence it's local minimum. And if the second derivative is less than 0, it means that the curve is concave down at that point, hence it's local maximum. So the second derivative at 5 over 2 is 150, 5 over 2 cubed. It's not necessary to find the exact value because it's clear that it's greater than 0, and as the second derivative is greater than 0 at x is 5 over 2, hence t has a local minimum when x is 5 over 2. And that's all for this question.